Hey everyone, and welcome to this deep dive. We're going to be tackling the semiconductor industry today, and let me tell you, it's facing some pretty massive changes.
Huge changes.
Like, we're talking a wave of retirements that could wipe out decades of hard-won experience.
Right. And at the same time, the demand for new skills is just exploding.
AI automation, all that.
Yeah, exactly. So we're going to break down what's going on and most importantly, what it means for you.
But before we get into all that, I want to give a shout out to our sponsor, Advaco.
Advaco. Yeah.
Their expertise in vacuum pump remanufacturing and service is really top-notch.
It's essential for keeping the industry running smoothly.
Couldn't agree more. Precision and reliability.
Yeah.
That's what it's all about. So check them out at www.adevaco.com.
Definitely worth a visit.
All right, so back to our deep dive. I was checking out this report from the Semiconductor Industry Association, the SIA,
Oh, yeah, SSIA.
and they're predicting that the U.S. will need like over 160,000 new engineers by 2032.
Wow, that's a lot.
It is, and there's a reason for it. Over $250 billion in investments are flooding into the sector.
So the growth potential is enormous.
Huge.
But there's a catch.
Always a catch.
There's a projected shortfall of 67,000 unfilled positions by 2030.
67,000.
Yeah, think of it this way. That's like trying to staff an entire city with highly specialized engineers.
That's a pretty daunting task.
Yeah, absolutely. It's a massive challenge.
And it's not just about, filling those empty seats, right?
No, it's not just butts and chairs. There's something else happening here that's even more worrying.
Almost like a brain drain on a massive scale.
Exactly. You hit the nail on the head.
What's going on there?
Well, a full third of the current workforce is over 55.
That's a significant chunk.
It is. According to McKinsey, we're about to see a wave of retirements taking a huge amount of practical experience with it.
The kind of experience you just can't get from a textbook.
Right. It's not something you can learn overnight.
Imagine the most skilled person you know at your job, the one everyone relies on for their expertise.
The go-to person.
What if all that knowledge just disappeared?
Poof, gone.
That's the kind of risk we're facing here.
It's a significant concern, and it's what we call tacit knowledge, this expertise that comes from years of hands-on experience.
Solving real-world problems, coming up with creative solutions.
Exactly. It's incredibly difficult to capture and pass on.
Okay, so we've got this looming talent shortage, a wave of retirements on the horizon.
And to make matters even more interesting,
Wait, there's more?
oh yeah, AI and automation are transforming the industry as we speak.
Wow, so what's happening there? Fill us in.
Well, it's not just about replacing jobs, it's about fundamentally reshaping them.
Okay, so how so?
Well, the CEO of Tokyo Electron predicts that by 2030, AI applications will dominate 70% of the semiconductor market.
70%, that's huge.
It's a massive shift in how chips are designed, manufactured, and used.
So what does that actually look like in practice?
Imagine this, instead of humans painstakingly inspecting every single chip for defects, AI algorithms can do it in a fraction of the time with incredible accuracy.
That's impressive.
And McKinsey estimates that this kind of automation could slash manufacturing costs by up to 17%.
So for anyone out there thinking about a career in this field, it's not just going to be about traditional semiconductor engineering anymore.
Right. Companies are going to need people who can bridge the gap between AI automation and that core engineering knowledge.
That's a whole new skill set.
It is, and it's a skill set that's in high demand. LinkedIn's data from 2024 shows that AI and machine learning roles are booming.
What kind of salaries are we talking?
Well, for example, AI systems designers are already earning an average of $173,000.
Wow, that's pretty enticing.
The industry is clearly heading in this direction.
Okay, so to recap, we have a talent crunch, a wave of retirements, and a technological revolution transforming the work itself.
It's a lot to take in.
It does sound pretty daunting, but...
But there's a silver lining.
Oh, tell me more about that.
Well, we're not just talking about filling the same old jobs. We're talking about preparing for jobs that don't even exist yet.
That's an interesting way to look at it.
And that's where education comes in.
Okay, so instead of just focusing on filling the gaps, we need to equip people with the skills and knowledge to thrive in this constantly changing landscape.
Exactly. We need a workforce that's not only technically skilled, but also adaptable and able to learn continuously.
Because let's face it,
the only constant in this industry is change. We need to kind of future-proof the workforce, you know?
absolutely future-proof it.
Yeah.
Are there any organizations out there doing this, well, like really getting ahead of the curve?
Well, there are a few, but one that really stands out is Roots Education Co. They're doing some fascinating stuff with training in robotics and mechatronics.
Okay, what makes them so different?
Well, they're all about real-world applications. Their whole curriculum is designed to give students practical skills, things they can use right away.
Like what kind of skills?
Things like programming, installation, maintenance, that sort of thing. It's not just theory, they're giving people hands-on experience.
That makes a lot of sense. In a field that's evolving so quickly, being able to adapt and actually use your knowledge is key.
Exactly. And another thing Roots does really well is engaging students early on.
Oh, that's smart.
They've partnered with schools to introduce STEM concepts to younger kids, help build that interest in tech careers early.
It's never too early to spark that passion, right?
Exactly, catch them young. But what about people who are already working, maybe looking to transition into these new roles? Does Roots offer anything for them?
Yeah, that's a good point.
Absolutely. Their philosophy is imagine, educate, integrate, and it applies to both students and professionals.
I like that.
They really immerse people in every stage of robotic work cell management, give them a deep understanding of how these systems work, how to troubleshoot them.
So it's not just about teaching them to program a robot. It's about how to think critically about the entire process.
Precisely from design to implementation to upkeep.
It sounds like Roots Education Co.
Yeah.
is really onto something.
Yeah.
This kind of forward-thinking approach to education is exactly what we need.
I agree. They're a great example of how to bridge the gap between the skills we need now and the skills we'll need in the future.
We've talked a lot about the talent crunch, the wave of retirements, AI, the importance of education, but there's another piece of the puzzle we haven't touched on yet, the legal side.
Right. There have been some developments recently that could have a big impact on the industry.
Yeah, the Global Foundries and IBM case comes to mind.
Exactly. It raises some interesting questions about how companies are navigating these changes and how intellectual property rights play into all of this.
For those who haven't been following this case closely, could you give us a quick rundown of what happened with that lawsuit and settlement?
Sure. So back in 2015, IBM transferred its semiconductor manufacturing business to Global Foundries.
Okay.
The deal was worth $1.5 billion and included Global Foundries supplying IBM with advanced chips for a decade.
Sounds like a pretty straightforward agreement.
Well, it seemed that way at the time, but things went south when Global Foundries allegedly couldn't deliver on the promise of 7-nanometer chips.
Which were crucial for IBM's next-gen systems.
Exactly. IBM sued, claiming breach of contract and billions in damages. Global Foundries countersued, alleging trade secret violations. It was a mess.
Wow, so what happened?
They ended up settling out of court, but the details are confidential.
Sounds complicated. What does all this mean for the industry as a whole?
Well, for one thing, it shows just how complex these partnerships can be, especially when you're dealing with cutting-edge technology that's constantly evolving.
And the stakes are high.
Absolutely. And if we connect this back to our earlier conversation about the talent shortage, it really highlights the need for a workforce that's not just technically skilled, but also understands the legal and business side of things.
It's not just about building the chips. It's about the whole ecosystem that supports their development and production.
You got it.
Speaking of the bigger picture, there have also been some interesting developments on the government funding side.
Oh, yeah, the CHIPS for America grant is a big deal.
Absolutely. Awarding $285 million to the Semiconductor Research Corporation Manufacturing Consortium Corporation in Durham
The SRC.
to establish Smart USA, that's the Semiconductor Manufacturing and Advanced Research with Twins USA.
Catchy acronym.
It's a significant investment, but what exactly are digital twins and why is this funding so important?
That's a great question. Digital twins are basically virtual models of physical things. So in this case, we're talking about virtual representations of chips, machines, even entire manufacturing processes.
So like a virtual sandbox where engineers can experiment and test things out without real-world risks.
Exactly. Think of it as a high-tech simulator for the semiconductor industry.
That's cool.
Engineers can use these digital twins to design, develop, and test new processes or even entire supply chains digitally before applying them in the real world.
So it can really speed up innovation and help companies avoid costly mistakes.
Absolutely. Using digital twins allows engineers to try out design changes faster and test them in a simulated environment, which can lead to huge efficiency improvements and reduce the time it takes to get new chips to market.
So it's not just about building more chips, it's about building them smarter and faster.
Precisely. And the Smart USA initiative recognizes that it's investing in the research and development needed to push the boundaries of what's possible in semiconductor manufacturing.
It's a huge vote of confidence in the future of the industry, especially here in the U.S. So we've covered a lot of ground today. Talent shortages, the wave of retirements, the rise of AI, the importance of education, legal battles, and even government funding. It's clear that the semiconductor industry is at a pivotal point, facing some major challenges, but also incredible opportunities.
It's a fascinating time to be following this industry. It's amazing how interconnected all these factors are. The talent shortage is linked to the wave of retirements, which is made even more complex with the rapid advancements in AI and automation. It's a tangled web of challenges and opportunities all happening against a backdrop of growing global demand for semiconductors.
So what does all this mean for our listeners? Whether you're an experienced engineer, a student thinking about a STEM career, or just someone who's interested in technology, these trends are going to have a ripple effect across the board.
Absolutely. The decisions being made today in the semiconductor industry are shaping the technology of tomorrow. Everything from our smartphones to our cars to how we interact with the world around us is going to be impacted.
Here's a question to ponder, given the rapid pace of change. What skills or knowledge do you think will be most valuable in the semiconductor industry 5 years from now? How can you prepare today?
It's a question worth thinking about. One thing's for sure, the industry isn't waiting for anyone to catch up. It's evolving at an incredible speed, and those who adapt and learn will be the ones who thrive in this new era.
That's some great food for thought.
Mm.
Maybe check out Roots Education Co. or learn more about how AI is being used in semiconductor manufacturing. It's a rabbit hole worth going down.
It really is, and who knows, maybe the next big breakthrough in semiconductor technology will come from one of our listeners.
We love to hear that. Thanks for joining us on this deep dive into the semiconductor industry. Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible. It's interesting. We talked about how crucial experience and that, tacit knowledge is in this industry.
Oh, absolutely. Yeah,
Yeah.
that deep understanding you get from spending years on the job.
Yeah.
It's invaluable.
But with so many experienced folks heading into retirement, how do we make sure all that knowledge doesn't just vanish?
Yeah, that's the million-dollar question, isn't it? There are a few different approaches being explored.
Like what?
Well, some companies are starting mentorship programs,
Oh, interesting.
pairing up those seasoned engineers with new recruits to help with the knowledge transfer.
Kind of like an apprenticeship model.
Exactly. It's all about giving those veterans a chance to share their insights, the tricks of the trade, their unique problem-solving techniques.
That hands-on guidance can be so powerful.
It really can.
Yeah.
But then there's the knowledge that's tougher to put into words, those almost instinctual things you pick up after years of experience.
Yeah. How do you even begin to pass that on?
That's where it gets really tricky. Some organizations are experimenting with knowledge management systems.
What are those?
Think like sophisticated databases where engineers can record their experiences, best practices, lessons learned.
So building a sort of institutional memory bank.
Exactly. It's not a perfect solution, but it's a good starting point. And as
Like a-
AI and machine learning keep advancing, who knows?
What?
These systems could become even smarter, able to analyze and pull insights from mountains of data, maybe even spot patterns that humans would miss.
That's pretty amazing. It's almost like we could create AI systems that embody the wisdom of an entire generation of engineers.
It's a definite possibility, and it's something people are actively working on. The future of semiconductor manufacturing is probably going to be this blend of human expertise and artificial intelligence, each one making the other even stronger.
So for anyone listening who might be feeling a little overwhelmed with all of this, maybe even intimidated by the speed of change, what's the one piece of advice you'd give them?
I'd say embrace lifelong learning. This industry is constantly evolving. So be curious, be adaptable, and never stop seeking out new knowledge and skills. The opportunities are out there for those who are willing to grab them.
I love that. A mindset of continuous learning. That's really the key.
Yeah.
Well, we've covered a ton of ground today, from the talent crunch and the rise of AI to the role of education, those legal battles, government funding, and even the challenge of preserving that hard-earned tacit knowledge. It's crystal clear that the semiconductor industry is at a crossroads, a moment packed with both uncertainty and incredible potential.
Absolutely. It's a dynamic landscape that's going to have a huge impact on all our lives in the coming years.
And with that, we want to thank you, our listeners, for joining us on this deep dive into the semiconductor industry. We hope you found it informative and insightful, and maybe even a little bit inspiring.
We hope you learned something new.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.